Kyle, when you're ready, you can turn on the
Okay, well, how's it going, everybody? As we all know, we just kind of went to a little bit of a talk with hurricanes going on next week. Obviously, a lot of attention is paid to hurricanes because, for one, they are the number one storm that caused the greatest destruction, obviously due to their surface area, so that actually makes them the deadliest storm in nature. However, tornadoes are the most violent, and with tornadoes, it actually is more difficult with them because of their prediction. It's a lot more difficult to predict tornadoes because they happen at such a small scale, at a very local level, and for that reason, a lot more attention is actually being paid to them. As far as research, storm chasing, why we see storm chasers setting up these instruments to capture air pressure changes, temperature, humidity, of course wind speeds, because from those kind of measurements we get to see the changes that go on inside the tornado, how these changes are taking place. This kind of data is taken back into the lab and is then further analyzed by specialists in mathematics, computer science, to formulate complex equations from this data, and that is how our forecast systems are further advanced. Our current warning time is around a half hour, between 15 minutes to a half hour before an actual tornado strikes. I'm sure we can do better than that to increase it to an hour to 2 hours, but again, that all depends on what we are doing out in the field, capturing these measurements. Now obviously with real-life tornado events, they are very rare. Okay, we get about tens of thousands of thunderstorms happening every day, and out of those tens of thousands, only less than a fraction of them produce tornadoes. And for that reason, it's very difficult to capture sufficient amounts of data from tornadoes to provide enough to forecast our warning time better. Now, that's where tornado machines come in place. If that we were to approach the field and better advance in the design of tornado machines, we can actually have everything under control, capture that similar kind of data that we want in the field in a lab. But again, depends on how realistic the model can be at scaling down all the ingredients that we at least know of now of tornadogenesis. Tornadogenesis is a good term to note down. That is still actually a theory. The research that's been going on through tornadogenesis has been going on since the past 50 years, and still is very productive today through storm chasing and model building and so forth. Just to start off here, this is a very basic design of a tornado machine, very small scale obviously compared to what I have in the garage. This is the tornado machine that I have used when I was a sophomore. That kind of launched my science fair projects, and just doing some simple experiments with this model to kind of give an understanding to how air convergence works with updraft, how inflow happens at different degree angles. And from this information, I put it into a letter that I sent to CPS Student Science Fair Inc., along with some designs that I made on my own, sketch drawings that you'll see in a few moments later on, that I sent to the Science Fair Inc., and provided all my results, and they reviewed it, and that's how I was awarded this Maxi research grant of $500 to provide the materials necessary to build this 8-foot machine in my garage. Each of these column boxes that you see of the large-scale machine is reinforced with plywood, which were sawed out 36 times to have each fan reinforced in the box. That's why they're nicely in place with the circumference of the openings. Now with this machine, the inflow is provided by an intake fan behind the center updraft fan, and is pressurized by the intake fan blowing air into the machine, pressurized chamber. And that air is emitted as inflow from each of these 6 pipes. The special term for these pipes are called circulation manifolds. Each of them are aligned with the holes necessary to emit the inflow. Inflow is another special term simply referring to air going into the center of low pressure, where the storm is located, usually the tornado. And the inflow can be varied by different degree angles, as I'm going to simulate here. By simply rotating each of these pipes to degree angles such as 30, 60, 90 degrees, we are replicating how wind shear in nature is intensified by environmental winds, shifting at different directions, at different altitudes in the atmosphere, and depending on how tight that these inflows are going in at certain degree angles, can further intensify a very strong rotation of air within the supercell called a mesocyclone. Mesocyclone is a very intense rotation of air within the supercell. And it's the mesocyclone that produces an updraft, an exhaust of air in the storm, and that pulls up this inflow that's happening near the surface, near the ground. And with that combination, we have a tornado to form. Also, the mesocyclone within the storm constricts and contracts. With the constriction, indicates that these inflow angles are further going at tighter air convergence, and it creates an overshoot near the top of the storm. And we see that on visual satellite imagery to indicate that there's tornadoes are in the process of formation. But where we see near the surface, we see a lowering. We see a rudder-shaped cloud known as the wall cloud that lowers from the base of the thunderstorm. And that wall cloud further rotates and further intensifies its constriction to what we see as a funnel cloud. And that funnel cloud further lowers to a full-blown tornado that we got here. Now, there's things that can happen with these tornadoes where if it becomes intense enough, it can form multiple vortices. Usually in the EF4 to EF5 Vegeta scale rating system, those are the type of tornadoes that can actually form multiple vortices. And why that is because with the very intense wind speeds happening near the ground, the inflow exceeding the speed of the updraft above, the mesocyclone above, there's an imbalance in the ratio called the throw ratio, where it explains that with the reduction in air pressure taking place in the center of the tornado, influences a downdraft of air to shoot downward from above, and that downward motion causes the tornado core to widen, and within this thin outer layer wall of the tornado, it splits into these multiple vortices, with the updraft still causing an influence for each subvortex to try to rise and fly up with the updraft, and we visually see that as multiple vortices, and there's usually between 3 to 4 of them in most cases. Now, some just visual animations here to better demonstrate the basic process of how tornadogenesis works. Now again, still keeping in mind that tornadogenesis still is a theory. What you're about to see has not been proven exactly, but based on measurements, what we capture out in the field, we know a little bit about it at least. Now, it's theorized that the tornado formation process begins as a horizontal rotational tube in the lower atmosphere near the surface. And that is caused by shifting winds coming from the southwest, south generally, and cooler air sinking, cold air being dense, of course, as we know, is near the ground, and stronger winds aloft creates this horizontal rotation of air. With the sun heating the ground during the daylight hours, it creates this bubble of warm air, pushing this horizontal tube into a vertical position. Okay, and as it goes upright into the vertical position, environmental winds, wind shear, shifting winds at different altitudes, intensifies this vertical rotation of air, and this whole thing is called a mesocyclone. And this is what we see as the mesocyclone, that very strong rotation of air within the supercell. And this mesocyclone, when it constricts, as noted before, is what causes the lowering for tornadoes to happen. Now, just moving into what kind of research is being done. To better understand this, an example from Iowa State University, located in Ames, Iowa. They do particular research with building tornado machines. And this video from this website does not work on here because of the network, I guess, from the school. But at least you can see the image on the left there is Iowa State's model. It grows about 8 feet in height. They can actually change the height of their tornado model there. But above it is this huge chimney-shaped mechanism that they can have on a track suspended on the ceiling, and they can move it around remotely. So they can actually experiment with differences in wind vectors happening as the tornado translates along the plane. They have built little model structure buildings to explain how certain structured building designs withstand tornadic winds to better engineer our buildings. And from the meteorological standpoint, they use the model to understand how the airflow works as it goes into the tornado, what's happening inside of it, and doing exactly what they do out in the field, storm chasing, taking pressure readings, air temperature, humidity, and of course wind speed with their model. So basically same exact thing that I was doing in my garage with a somewhat different design, which I would like to just go through presenting now. What we have is some actual video that was taken by me. So this was the original video of my tornado machine. I'm just going to keep the sound down low right now and just kind of first go into my design. You're going to see the original sketch drawing that I have made. Just make sure, here we go. Now, if you would like to see the whole video, you can refer to my YouTube link, which is Toto1228, TOTO1228, where additional links can be found from WGN and Discovery Channel, which we will see after this. But this is basically how everything started with my large-scale tornado machine project, was me beginning to design this. This is the very first drawing that I made that kind of just exploded from my mind. You know, I can't really explain how this came together. It was just something that I started to imagine, and it was a dream that kind of pushed me to, thinking about how fascinating it would be to build something so large scale in a garage. You have an 8-foot tornado. So that's what urged me to begin my own designs that would provide more variables. That's a really extreme importance there, because being able to have more variables to manipulate the inflow fans individually, of course changing the degree angles, but additionally, what's additional with this design is that I can change the distance from which the air is coming from into the center. So basically how that works in nature is that inflow can go into the tornado at different distances and angles depending on how the mesocyclone is contracting or constricting, and resulting in tornadoes of different structures and intensities. But probably the most important variable with this design, and additional of course with this machine, is varying the updraft speed. So the updraft being the top suspended fan. So being able to vary the updraft speed allows me to work with the formula called the swirl ratio that explains at what value multiple vortices will take place. So basically, when we have the tangential, which simply refers to wind speeds occurring around the system, exceeds the speed of the updraft. So we have the updraft on a lower speed setting compared to the higher speeds of the inflow fans. It naturally causes a reduction in the air pressure in the core of the tornado, and that causes a downdraft of air to shoot downward from the top to go downward, and that enlarges the wall of the tornado. And as this wall becomes a little bit thinner, the updraft influences to break it apart, separate into these multi-cells, and that's what becomes multiple vortices. And being able to capture the measurements that take place at the time they form is very revolutionary because they are associated with violent tornadoes, so we get to see at a scale what those measurements are that are associated with violent tornadoes. Now, I'm just going to present some various perspectives that were taken here. Some special effects were added, as you can see, but just to scroll through to the point where you can see where the tornado was born for the first time. It was at this segment here. Let me just push this back here so everyone can see.
Is that your eyes?
Yes, sorry about that. Now, yes, this was dry ice to simply visualize the tornado. It was an artifact in a way, just used as a visual. It didn't really cause any major change in the measurements from dry ice temperature. But what was important was measuring how fast this tornado was spinning. And also taking air temperature and air pressure readings. For video purposes, this is an anemometer to measure wind speed. For video purposes, I simply demonstrated how the anemometer works to measure this. For my initial experiments, all the instruments were suspended freely from the updraft fan, because as you can see, when anyone is inside the chamber, the tornado is effectively breaks apart. So we want the tornado to retain its structure as the measurements were recording it. So that's why they were suspended from the updraft fan. But this is basically a video showing how everything is designed here. The updraft fan is suspended 8 feet above the ground. And I was able to actually have 3 fans per column, 4 columns each. As you can see, they're attached freely from any other structure, so each of these columns can be pushed back to move forward to vary the distance of the inflow. And so that first segment there kind of introduces how that design is physically set up. Now, into actual video of the multiple vortices, this simply shows vortex breakdown. You can see there the multi-cells breaking up, and then the updraft causes a little bit of an influence to make them rise into multiple vortices. And you can kind of see right there, let me just pause right there so you can kind of see what they look like. You can actually see each one individually. Beginning on the one off the left here, you kind of see a funnel structure in the center, and one just breaking apart off to the right if everyone can see where those multiple vortices are. Okay. And again, to keep in mind with multiple vortices, each sub-vortex cannot make one full revolution around the tornado. They make about 1/4 around the main funnel. And so when you see the actual video that I took of my machine, when we just scroll to that, you will see that they happen very quickly and briefly. It may be difficult to see. But again, they are happening. Let me just scroll back here. There we go. There's about between 3 to 4 of them that happen. Again, because everything's so complex at the surface here, is why they break up so easily. But they do go on and off flashing, and that confirms that I did receive multiple vortices. Just another perspective here for the formation of the single vortex. Now the updraft fan is set to a higher speed, and the inflow fans are lower to properly set up for the 8-foot single vortex tornado. I do give a summary right after this clip here of how the whole machine skull is, why it was made. So I just want to maybe listen to that. Hello, ladies and gentlemen. I'm Kyle Swartz, and I'm the junior engineer and scientist for the project titled Tornado Genesis Multiple Vortices. As everyone can see, I have designed and constructed a large-scale tornado machine for the operation of a 7.5-foot tall tornado. This machine provides many things to change and manipulate, allowing for the experimentation of multiple vortex tornado genesis. Tornado machines can provide a better understanding to the mechanics of tornadoes What can be discovered from their use may help to further advance tornado forecasting and ultimately save more lives. With severe storms and where they happen, they are always associated with systems of low pressure. Now with tornadoes like hurricanes, they do have a calm center high where it's located, the lowest pressure takes place. And you guys must have seen the video last week of Reed Timmer and his team chasing tornadoes. He actually has a car of his and he built armor around, so he can actually intercept tornadoes and have the tornado directly impact him. And when that happened, their ears were popping, so to kind of indicate that major pressure change that goes on in the center of tornadoes. So let me just stop here and also explain the future design here. Again, this is a rough, simple design that I have for the future. Now, as you can see right away by the notes, turbofan engines, high-powered rotor system, what helicopters use, indicates a very powerful lab tornado that may produce wind speeds comparable to a real vortex, having wind speeds between the EF2, EF3 category, between 145 to almost 200 miles per hour. This I can actually maybe produce from this design. But what I plan to advance with the design of this is using robotic arms to control each inflow fan individually. And what's special about that is that each inflow fan can rotate at 360 degrees around to possibly form a horizontal rotation tube of air to kind of support what we theorize that tornadoes really do happen with a horizontal rotation, and then have a very powerful heat source to heat the ground to create a warm updraft, to see how it may go into vertical position and have a very powerful updraft mesocyclone simulated above, to see how, if we can get a tornado to form based on those ingredients that we know of, that we can best realistically simulate as possible. So that would be the purpose of building an advanced design tornado machine, to replace how many failures we get out in the field and not intercepting tornadoes, when something like this would probably revolutionize the field of meteorology and ultimately increase our warning time significantly, saving our lives. Now we do have a segment recently from Discovery Channel, from Canada's network, and how this happened was the producers from Discovery Channel in Canada heard about me through several people in Chicago, and they saw links from WGN. And we're in the city doing several stories, and they were interested in doing a story with me. And it was back in June that I actually made a film production for 8 hours, filming in my garage. And it was in November 8th, that the broadcast finally aired. And it aired nationally in Canada, and they have various stations in Europe and Asia, such countries as Japan and England, where this was actually aired nationally here. Unfortunately, though, from Canada's network, they don't broadcast nationally in the U.S. But of course, we do get the link when it goes on, so you guys can see that. So here we go with this. There is a little commercial break, but I'm just going to start this up for everybody. So this was our recent segment from Discovery.
One weekend to do it. Raising the bar tomorrow on Daily Planet.
And their show is called
Next up,
Daily
though,
Planet.
we're going to show you a storm brewing in the Chicago area. A storm brewing inside a house.
All thanks to a young weather wizard named Kyle Swartz, who can call up a tornado just whenever he really feels like it, thanks to an amazing machine.
Most people would do anything to stay out of the path of a tornado, but not Kyle Swartz. He's got one in his garage.
This is a 7.5-foot tall tornado.
It may be a scaled-down version, but Kyle's dead serious about tornadoes. Creating one in his garage is his way of studying their formation and habits. It's an ingenious setup.
We have 4 columns each, and each one contains 3 inflow fans to provide inflow to go into the center circulation, and that is pulled up by what's called an updraft fan.
Kyle carefully sets the fan columns' angles and adjusts their speed.
Here we go with the dry ice. And now we will be visualizing the tornado.
In nature, we can see tornadoes because of lightning, swirling dust and debris, and condensation in the storm cloud. In his garage, Kyle submerges dry ice in very hot water.
The special name for simulating this process is called air convergence. Tighter air convergence, a more smaller diameter tornado, but much more intense rotational wind speed, which makes it dangerous in the area near the bottom corner region.
Kyle takes careful measure of his tornado to get an idea of its power, relatively speaking.
The wind speeds I clocked were about 40 kilometers per hour, so a pretty intense wind speed under these settings that we have on now.
That's only a fraction of the speed of a natural tornado, but the goal here is to create an accurate model of the real thing.
Real tornadoes, this garage would be completely destroyed, obviously.
Kyle's tornado machine was originally born as a science fair project.
The way it started out was just a simple drawing at my desk just over the summer a year ago.
But impressive as it looks, a simple tornado in his garage is not enough. Kyle's after something more ambitious, a multiple vortex tornado.
What's most important is simulating what's called multiple vortices by lowering the updraft speed at a lower speed setting while increasing the inflow fans at higher speed levels.
Multiple vortex tornadoes are a rare phenomenon. They're caused when the airflow entering the storm overwhelms the updraft in its center. The pressure drops and air falls down through the funnel, bursting its walls and giving birth to several deadly mini-twisters.
And now, ladies and gentlemen, we will be setting the conditions to form multiple vortices, the ultimate investigation of this project.
Kyle has the recipe for vortex breakdown worked out in advance. It's a matter of changing something called the swirl ratio.
And now we will just be lowering the updraft fan to a lower speed setting, and so as to apply the swirl ratio. And now I'll be increasing the speed of each of these inflow fans to go along with the parameter of the swirl ratio over the updraft speed. Highest speed is 22 kilometers per hour. And here we go. And now the dry ice. See, ladies and gentlemen, you can see within the cloud that we do have multiple vortices. Very briefly,
Kyle's tornado model allows him to create formulas so he can take info from real storms and forecast the results under different conditions. With better forecasts, lives can be saved.
It's a dangerous tornado. Really close.
to receive the measurements that take place as these changes happen.
We have a major tornado coming down.
It's a huge deal in capturing and applying to our advances in radar systems to detect these specific changes that take place.
It's right there, it's right there. Right there.
Further advance our warning time.
For Kyle, the tornado in his garage is just the beginning.
I plan for the future to improve on the designs of tornado machines to replicate as realistically as possible the real-life conditions that go on in actual storms.
That's a pretty impressive spin for a project just getting off the ground.
Clock me, Zaya.
Okay.
What that was to be able to share with everybody. So that was our recent segment. Again, if anyone has any further questions regarding about this and the beginning there of the tornado formation process and the machine itself, we could good this time.
Any questions? Just one or two before the bell rings, anyone? Any other questions?
Oh,
I have a question. Did you prepare any ideas?
well, here's the thing, that all my drawings are sealed. I'll never be opened by, so if something were to happen, you know, but further things, you know, they,
Have a great day,